welcome to THERMO Boys. Today we're going to be looking at simple mixing chambers where you just have cold and hot water mixing into a warm water. So we have some states here. We have temperature of the first water is 10 degrees Celsius at 100 kPa, hot water at 95 degrees Celsius at 100 kPa, and then the mixture is going to be 35 degrees Celsius at 100 kPa. And we know that the mass flow rate out of our pipe 3 is going to be 0.8 kilograms per second. So first off, we need to write out the energy balance equation. So we're going to get the change in energy of the system is equal to the heat transfer in minus the work out plus mass flow rate in times H plus KE plus the potential energy minus mass flow rate out times the enthalpy plus kinetic energy plus potential energy. So now we have to make some assumptions. We're going to assume that this is steady state, steady flow, so we can set this equal to 0. There's no heat transfer being represented here, so we just assume that's 0. There's no work being done by the system, so that's going to be 0. And we assume that there's no change in potential or kinetic energy, so all of those are going to be equal to 0. So now once we rearrange this, we get that our mass flow rate in times Hn is equal to our mass flow rate out times enthalpy out. So from here we can analyze that our mass flow rates in are going to be at 1 and 2. So we can get our mass flow rate 1 times H at 1, or enthalpy of state 1, plus the mass flow rate at 2 times the enthalpy state at 2 is going to be equal to the mass flow rate at 3 times the enthalpy state of 3. Okay, so now we can get all of our enthalpy values from this data using table A4 in the textbook. So from there, we're going to get that H1 is equal to 42.022 kilojoules per kilogram. H2 is equal to 398.09 kilojoules per kilogram. And then we have H3 finally at 146.64 kilojoules per kilogram. So once we put those in, we have H1, we have H2, we have H3. We're given mass flow rate at 3 here, so that's not a problem. So we just have 2 unknowns, which are mass flow rate at 2 and 1. So now, because it's a mixing chamber and we assume steady state, steady flow, we know that mass flow rate at 1 plus mass flow rate at 2 has to equal the mass flow rate at 3. Otherwise, we have losses that we just don't know. So from here, we now have 2 equations and 2 unknowns, and you can just solve this as a simple system, and you can get that your mass flow rate at 1 should be 0.565 kilograms per second, and our mass flow rate at 2 is going to come out to 0.235 kilograms per second.